Hey folks, I wanted to do a little bit of a run through of the answer key for the instantaneous velocity calculations. Right off the bat, I want you guys to see these are busy pages. It took me quite a while to make the answer key. It even took me a few attempts. I started here, realized it was getting messy, started doing some calculation, realized that it wasn't going to work the way I was doing it. Take your time, plan it out, and then take your time again. This is going to take a little while. It's going to get messy. Try to do it one step at a time and your life will get a little bit easier. So if we take a look at our answer key here, I didn't want to do it live in front of you because it took me a long time. I'm sure you guys took a while to do it as well. I hope, because it would have turned out better. You can see all of my tangent lines. It's kind of neat looking at the tangent lines because you can actually see they get steeper as time goes on. It makes sense since we are accelerating at the start, decelerating or negative acceleration for a little bit. They turned around, accelerated, and then slowed down again. So there's your story. You're supposed to tell the story of the car at the end. That's a really basic story. You could make it a little bit more interesting by saying why they're accelerating. Where are they accelerating to? Why did they slow down? Why did they turn around? Where were they going back to? What did they forget? Did they drop something at 40 meters? Who knows? The calculations. You might be able to see in the scans, I've got some green dots and I've got some red dots. What I did for each tangent line, I gave myself a little green dot of where it had good coordinates and a red dot where it had good coordinates, so I can see where this line started, where this line finished, because it's not actual motion, it's just representative of the motion. And we can see easily that in 10 seconds they covered 10 meters for 1 meters per second. The little bit of a faster line found at 5 seconds, they were going about 3.13 meters per second. At, where was it? 9 seconds, they were doing about 11.7 meters per second. And then at 20 seconds, we can see the slope of the line changes from a positive slope to a negative slope. That just simply means they're moving backwards or back towards the origin. So the negative is important. It just means left or backwards, back towards the origin, negative. Your lines are not necessarily going to look the same as mine. They should look very close, but it should still show the general trend. These numbers don't need to be the same. These are the numbers that I spotted easily on my line. You might find slightly different numbers on your line. In the end though, you should have a speed that is very similar to mine, quite close. If you're getting numbers that are way off, let me know. We'll talk it through. We'll try to figure out where the issue lied. So that was the first part. You had to make 4 tangent lines. They got a little messy, but you did good. Question number 2 got super intense because you had 1, 2, 3, 4, 5, 6, 7, 8 different tangent lines on a single graph. You can see all the different lines I made. I ended up doing all of my calculations on a separate page, and I did one line at a time. So I drew my line for 0 seconds. Before I crowded it with the rest of the lines, I found my 2 spots, which was 15 meters at 2.5 seconds and 0 meters at 0 seconds to do my calculation. I even had some whiteout that I had to go back and find my mistakes, because mistakes will happen. Just if you're going slow enough and you're checking over your work, you will find it. It'll be good. All of my slope calculations, we've talked about them a ton now. I moved them all into my data table so I can see that my velocity was decreasing fairly consistently. 6 seconds got a little bit funny, but maybe my line was a little off. Maybe the curve isn't quite constant. It's probably a me error, not a curve error. So 0 seconds, approximately 6 meters per second. 2 seconds, about 5 meters per second. You can read. Now, the last thing you were supposed to do here, as you read part 2, you're supposed to take the data table of speeds versus time to make a speed-time graph for the motion. Graph paper should be included, and then you had to find the slope of the line, tell us what the units of that slope would be, and then what that slope actually tells us. So we're gonna get rid of these calculations for a second. You have a copy of them all. here was my speed versus time graph. Time is our independent, so it goes on the x-axis. Speed is our dependent, so it goes on our y-axis, spread out between 0 and 6. I wish I could have spread it out more here, but unfortunately it didn't line up that well. We can see most of the dots actually lined up quite well, so my line of best fit wasn't too hard to make. Here was a big outlier, but that's okay. Outliers happen. To get rise over run, I found 2 points that fell nicely on the line. I found one here at, what was that, 2 seconds? Nope, that was at 3 seconds. And I found a nice little spot here at 6 seconds. If we find our rise, it's going down, so it's actually negative 1.25 meters. And then if we did our run, it goes from 3 seconds all the way up to 6 seconds for a total of 3 seconds. Our calculation down here. I really like to include the units in the calculation because it helps you figure out your units at the end of the question. Our rise, negative 1.25 meters per second, divided by 3 seconds, gives us negative 0.42 meters per second per second. So I really hope that you made it obvious that your units were meters per second, which means it tells you how much your speed is changing per unit of time. And it tells us actually our rate of acceleration, which is going to be the next thing we do. Any questions, please ask in the open chat or privately if you're a little bit shy. It just helps everyone see that everyone is confused on the same stuff. Awesome, thanks.